Hi, everyone. You guys can hear me, right?
Yes.
Okay, cool. I'm Max. You may have remembered me because I did the other front end presentation. Now I'm back to do more front end stuff. So it's kind of exciting a little. But we will just jump on into things. So welcome to our 7th workshop. We're pretty far into it, so congratulations on making it this far. Something that is something to be proud of. So let's begin. We're gonna first start talking about for advanced front end. We're gonna talk about the first thing we're gonna talk about is React Router. So right now in our landing page, it's kind of static. If we want to display a component, such as if we wanted to display the create blog post component, what we had to do was import that component and then manually manually put the tag create blog post so that React would know to render it. That's not the most ideal situation because we want to kind of have the user be able to navigate around the front end and kind of click a button and that button be able to bring them to the specific component, which then React renders. And so what we can use in order to accomplish this task is something called React Router. And what React Router is just a framework that helps us add routes to our front end application. What I mean by routes are kind of links between different components so that just think about when you click a button on like a nav bar and it brings you to another page. That's what I mean by routing. So we're going to have the idea of all of our components are going to be interconnected. So that way it is a lot easier for us to switch between components. So what is React Router? As I just said, it's a third-party framework that adds routing to an application. So it's not part of React per se, but it is a useful library that a lot of React applications end up using. Like I said, routing is the capacity to show different pages to the user. So it's like I just said, if you have if you go on a website and you see at the top it has different buttons to different pages, and you click one and then the page shows up, that's routing from the home page from where you landed on, or the landing page, to the route that you clicked on. And so this means we can move through our application by entering a URL or clicking an element such as a button. So we talked about how you can route through clicking a button, but you can do the same thing. The button basically just changes the URL. And so now the URL can point to a different part on your website. So the first thing we need to do when dealing with React Router is setting up the React Router. And so what I mean by setting up the React Router is that we need to configure our routes. So we need to know, or we need to establish what our specific routes are in our application before we can use them. And so for this, we're going to use 3 different components from the React Router library that is browser router, switch, and router. Or it should be route. Sorry, that's a typo. But the third component should be just route. The props that we're going to need to use for these components are path component and exact. I'm going to get into that in a little, but we are going to just go ahead and see what it looks like. So this is what the React Router kind of setup will look like in your app.tsx. So right now in our app.tsx, we just display the landing page. and that just displays, or we can display the create blog post component, or we can display any component we want. But if we want to switch components to display, we have to re-import them, and that is very inefficient. So what we use is these three different components from the React Router library that allow us to add functionality for the React Router. So the first one that I said, if we go back a little, was browser router. And usually what we like to do, this is a really long name, so we like to import it as a different alias. So in this example, I imported browser router as router. So wherever you see router right here, browser router and router are the same thing. So basically the router component, everything in between the tag is going to be able to be used in the routing. This is mainly like a wrapper tag to define what we're going to be used when in our React or in our application that needs routing. The switch component is used to switch between multiple routes. So usually you'll wrap your routes in a switch tag to signify that when a specific path is clicked on, the React application will render that specific route. And so what switch allows us to do is render or to have multiple routes in our application. Finally, the last component is route, which just specifies a route. And as I said before, we have these three props that we need to include. We have path, component, and exact. So the path prop just is the URL location of the route. So if you were to type in on if you were to run this locally and it was on localhost port 3000, if you just type that in, you would go to the whatever is just slash that. However, since we're trying to, this example is trying to show what or how to create a route for the create blog post component, we may want to put that route at localhost port 3000 /post/create. So now whenever that URL is typed in the browser, it React route or the React application with the help of React Router knows that this route is linked to this specific component. And the component it knows to be linked to is defined through the component part of the component prop. So that leads me to the last prop, which is exact. And the reason we don't need to specify a value for exact is because exact is a true false prop or a Boolean prop, which means just including it means that exact will be true. And if exact was not included, exact would be false. So what exact means is that the path to link to create blog post component has to be exact. So if we were to include a path, let's say /post/create/for, what the React application, your application will still render the create blog post component. And this is due because the React router will just check if the path is equal to basically the first thing in what you typed in to the URL. So if you were to type in extra stuff past this path definition we have, it wouldn't matter because React, the switch statement just switches it to the first the first thing it is equal to. So what exact allows us to do is say that the path has to be exactly this. So if we append something, so if we do /post/create/for, it won't link to the create blog post component because it's not exactly this path. Any questions so far on how to set up React Router? I'm gonna take that as a no. feel free also to ask questions anytime, and we'll just answer them. But we're going to move on to now, since we set up our React router in the app.tsx, which is what this code does. This is in app.tsx. We now want to use that in our application. So for example, in the nav bar, when we click the button that we made, create or add a post, we actually want it to now link to the create blog post component. So what we need to do is first import a specific component from the React router library, which is link. And what link allows us to do is use or link between two components. The two props that we're going to need to use in our button are the component prop and the to prop, and we'll kind of see what they are in a second. So an example, we have this button in our, I think it's our nav bar right now, and it just says add post, and it has it's just a large button, and you know, it has a specific class, but all it does is just when you click it, it's just a button. So how would we make this button when clicked to go to the create blog post component? And I don't expect anyone to know this, but using the link we imported and these two props that we can add to the button, we can make this button link to the specific component we want. Let's see how that works. So first, we use the component prop to basically cast this component as a link. What I mean by cast is if you have ever taken any other programming languages, when you cast a type, what we're doing now, this component prop basically says this button is also referred to as a link. So it basically just adds extra functionality. The to prop is basically where all of the logic is, and it's basically saying where is this button leading to? And so we want this button to lead to the route or the path that we established for the reroute for create blog post. And if we go back, we can see that that path was /post/create. And so remember, once we type this path into the URL, we should display the component create blog post. And so having this to prop allows us to, having the component be a link allows us to, when the button is clicked, it will take us to whatever the to prop is. And having the to prop be /post/create, that route is set to be the create blog post component. And so in turn, when we click this button, it will take us to the create blog post component. That's basically React Router. Are there any questions so far before we move on? All right, I'm gonna take that as a no, and I'm gonna keep on cruising through this. Hold on 1 second. All right. So the next thing we are going to talk about is this thing called async. So JavaScript is fundamentally a synchronous language, which means that each function call or each line of code is kind of executed one after the other. And this is kind of what we're, I guess, used to also in other programming languages. But the question then becomes, what if we have a function call that may take a while? Let's say it may take like seconds when we still, when we only want to take like a nanosecond to execute. We don't want our program to halt waiting for this long response time. The solution to this is that we can have an asynchronous function. an asynchronous function basically runs the code or runs the function in the background and continues to execute the other functions below it or below it in line. The keyword that allows us to have this asynchronous functionality is called async, and it basically enables us to it basically defines that the function will run in the background, and the keyword that actually allows us to wait for the response is called await. Let's just take a second and look at an example. So right now, this is just an example in code. So we have a request that we are making to this random, let's just say, address on the internet. It may take a while for data to come back. And we want to then console.log this response. What will happen with this code right now? Does anyone know? You can take a minute and we can just try and figure out what right now, if we ran this code in coding in an environment, what would we console.log? Close. It doesn't return a promise. The response will be recorded in console.log, but the request, as we said, will take like a couple seconds to make. We would want it to wait for the response to come back, then log it. But remember, what I just said before was the keyword await allows us to wait for the response. Basically, you guys, these are all right answers. But what this will actually do right now is it will console.log undefined, because the response right now is going to request data that may take a few seconds to come back. So right now, response is undefined because the request has not come back yet. And what we do is immediately console.log response, which is undefined. So we're not waiting for this request to finish before assigning it to response. So console.log would actually print out undefined. So the question is now, how do we fix it? And that looks something like this. We add await, the keyword await, to the request we want to make. And so now the response actually waits, or our JavaScript waits for the request to finish, and then assigns it to response, and then executes the code below. So yeah, as Connor is saying, request is kind of a predefined function in the JavaScript library, and it's an asynchronous function, which probably would have been helpful to say before I asked you. But what basically happens is, like Connor is saying in the chat, await forces the asynchronous function to, I guess, run synchronously. But and we kind of wait for the data that we get back to, I guess, print out response, if that makes sense. Let's move on really quickly to adding async. So just like what Connor was saying, we're going to be, let's just make a function for this called get response. And all we're going to do is return the data in the response like we're doing here. We just have this simple await request. However, since this function is now including a request, we now need to define it as asynchronous. So we add this keyword async to the front of the function, meaning that this function will be happening asynchronously. And yeah, that's kind of as easy as it is. the pattern that you will see is any function that contains wait must be async, and this is due to that we want to, or the request is happening asynchronously, and we want to await that request before assigning the value from that request to what the value that we want it to assign to. Calling asynchronous functions is quite easy. We don't need to define the function that calls an asynchronous function async. That's just basically all I wanted to say here. And yeah, if we call getResponse, JavaScript knows that getResponse is an async function, so do something does not need to be defined as async. Are there any questions about asynchronous functions and the keyword await? All right, I'm going to take that as a no, which is great, and I'm glad that you guys are getting it. Yeah, what Connor's saying. If you have any questions, just put them in the chat, and if I'm not seeing it or answering that, Connor will definitely get it. Let's move on to our next topic, which is APIs. And I think we've talked about APIs in the previous Jumpstart workshops, but nothing related to the front end. They've mostly been related to the back end. And so what we can think of the API in context of web development is it usually connects the front end to the back end. What an API is, what is kind of interesting and actually really beneficial from an API is that the front end doesn't need to know anything from the back end to make requests. All it needs to know is, I guess, the URL to make the request at, and we can just trust that the back end will get us the information we want with the specific request we put. And so this kind of reminds you of, if you've ever learned Java, this idea of an interface where we do not, well, an API is basically just an interface. Like we said, it's an application programming interface, and it basically allows us to, on the front end, not need to know anything about the backend code to get stuff from the backend, which is really helpful and beneficial because it allows different scopes in our application to be separated. An API specification, basically what, a defined API, I guess, should tell us the following three things. One, the different commands we can send to the backend. So yeah, that's kind of self-explanatory. Two, what inputs those commands need so that the backend can make sense of them. And so when I'm saying by commands, I kind of mean if we were to request data from the backend and we say we want to request a specific URL, because that's how you request data in the backend. If we flash back to a couple workshops ago, what this command is basically that that specification to that address. That kind of makes sense. It'll make sense in a little, but just stay with me. And number three is what, if anything, we should expect to receive as a response to each command we send. So the data we should get back. The request. So the first part of an API is the request. We usually, these are the most common types of requests to make. The first one is a GET request, which basically just gets information from the backend. The second is a POST request, which is used to create data in the backend. So it creates a new entry in the backend. Delete deletes data or deletes the specified data in the backend. Put is used to replace a resource in the backend. So if resources already exist in the backend, put basically replaces the whole thing. And then patch is kind of similar to put, but it's used to modify a resource. So while put replaces the whole resource, patch will only like update it or modify it, if that makes sense. So how can we so if we see right here, we're kind of making a get request, or this is how kind of I guess we would make an API request. It's not going to be specifically, if you see, it's not going to be just get slash. There should be a space in here, but this this command, this I guess request is going to be a get request to the location comments/ID. And that's kind of the specification that we say in the backend, which allows us to say, if we want to get a comment that has an ID of 42, what we can do is just say get, and then we can give the specific location, which is comment/42, and that will get us, we can trust that the backend will return to us. Sorry, my light's so weird. But that we can trust that the backend will give us the comment with the ID 42. Just as we can have single fields for our commands, we can have multiple fields. So let's say we want to get or we want to get a comment with a year and an author ID. We can just link them in tandem with one another. So we kind of get into this problem to where if we want to request a bunch of fields, how would we do that without having to make this super long URL request? So what I mean is, let's say we wanted to get the comments year, author ID, the ID of the post, let's say like the preview of the post, and we have like, let's say 10 more things. Our request would be get comments and then all of these fields that we want to get. And so this kind of is first unflattering to the eye, because that's just a lot of, I guess, words on a request that is going to kind of be confusing. So how, like, what I guess is a solution to this problem that we're facing? I'm going to kind of jump into it, and the solution that we get is the request body. So the request body basically is not essential to the request, but it does make it easier for us to get multiple fields of data. The request body is really any kind of textual data, but the usual, I guess, is the usual type of the body is formatted as JSON. JSON stands for JavaScript Object Notation. We may have talked about it in previously, but it's just really simple mapping keys and values in one object. So what JSON allows us to do is it allows us to basically have kind of a similar, God, I'm losing the word, but what JSON allows us to do is allows us the format for our body to be similar on the front end and the back end. And this allows for parsing to be easy with the request body on the front end and the back end. And so instead of making this, so going back, if we wanted to have get comments and we wanted like 5 different fields, instead of making this one call, we can just make one call to a specific field, and that field will return a request body. And this body may look something like this. So if we wanted to request a specific field from the backend, we might get back a body which contains multiple fields that we can parse. So this is written in JavaScript in JSON, which basically is saying that it, like I said before, it maps basically strings to strings in this object. Yeah, it returns an object that has a map from string to string. And what that allows us to do is associate a key with a value. And yeah, it's kind of as simple as that. Are there any questions on the request part before we move on to the second part of an API? I'm going to take that as a no, which is good. The second part is a lot more simpler because it's the response, and the response just it consists of two things, which is the status code of the response and the body of the response. So a status code is a quick look at what happened during the request. You may remember, I guess, from the previous workshops, but like a status code of 200 means the request was successful, while the infamous status code 404, or I think is 404 not found, or is that 401? 404 is not found, right? Yeah. So if you see on a website and you get the error 404, that's a status code signifying that the request you made was not found in the backend. And so there are a whole bunch of these status codes that allow us to basically take a peek at what happened during the request and what, like, I guess either went well or failed. And then the response has a body, which is also entirely optional, but we end up using it frequently. And the body just allows us to, like we said before, allows us to easily parse multiple fields. And so, like we said before, if we wanted to get comments, the body for that response would look something like this, where we have a comments, we returned an object, and the mapped, I guess, JSON is the comments is going to be an array that contains name and content. And this just allows us to easily parse and deal with the response body. Are there any questions on API specifications or anything I just talked about relating to an API before we move on? All right, that's great. I'm glad that everyone's getting it. And so we're going to kind of move towards our last, I guess, topic, which is going to be Axios. So Axios is an open source library, or open source NPM library that allows us to easily make HTTP requests. So if you're thinking, how do I, in the front end, request stuff from the back end? JavaScript does have some built-in ways to make this happen, but we are going to use Axios because, frankly, it's better to interact with, and it's a lot, and configuring it to do what you want is a lot more helpful and easier. I know the name Axios sounds really weird. I don't know why it's named like that, but it just is. So what Axios, like I said, allows us to do is fetch data from the backend, so we can use the response from our request to the backend to display in our front end. Yeah. So before we get into making requests with Axios, we kind of need to talk about this idea of promises. And what Axios is a promise-based HTTP request. And so what a promise is kind of an object that may produce a single value sometime in the future, which is either the promise will be like a resolved value, or an error that happened when we tried to, I guess, request data. Basically, a promise is a way for us to deal with return values from asynchronous actions, such as requests to different places on the internet or our backend. When we're dealing with a promise, we need to resolve our promises with a .then kind of call. And so basically this promise you can kind of think of is something that we need to resolve. We're promising to resolve this request in the future. And in order to resolve this request, we need to say .then to signify once this promise is returned, like once the request has returned, what should we then do with the, I guess, data we get back or the error we get back? So what we do is we put a callback function in the .then, which allows us to handle what the promise will do when it is resolved. So the promise has 3 different states. It either is fulfilled, rejected, or pending. Fulfilled means the promise returned successfully. Rejected means it didn't. And pending is the state in which the promise waits for the operation to be completed. So pending means we don't know if it's successful or not, but we're just going to keep waiting until the promise is either fulfilled or rejected. Any questions on promises really quickly before we move back into Axios? Yeah, sure. So a callback function is something, it's just a function that's defined that we can use, I guess, anywhere else in our code. If you want to think of a callback function, you can just think of it as a predefined function that we can use in a different place, almost. It's if we had a function that just says get something and it just like it did some stuff with I guess resolving the promise, we would just put get something in the .then, and it would be used to resolve the promise. As Connor also pointed out, there's also a .catch method, which allows us to do the same thing as .then. So .then resolves a promise when it's successful, and .catch resolves a promise when it fails. So yeah, that's just something else that is significant in promises, although we're not going to be using it with our application. I hope that makes sense. Does that make sense, Eugene? Yeah? Okay. And Connor also put in a pretty good definition that probably better than mine in the chat. So we're going to move on to Axios Instance. So proper practice for using Axios is to create our own configuration for Axios. And what I mean by configuration is kind of, where is the base URL? So where are we first requesting stuff from? And that may be something we want to stay constant. So we don't have to, for every Axios request, we don't have to say, I want to get from this base URL. And we'll kind of see actually in 1 second what Axios Instance may be. And what I mean by Axios Instance is just the configuration that I'm calling our Axios, or custom configuration that I'm calling our custom configuration for Axios in Axios Instance. And so what that is going to look like for us is this file. This is all that's in the file. We name it Axios instance.tsx, and basically all it does is with axios.create, create allows us to create a custom configuration for our Axios, and we are giving it these 3 different configuration, or these 3 different kind of custom configurations. So basically the base URL, not too sure what exactly this points to, but basically this points to kind of the base that we are making our request off of. So for example, a base URL for the front end is localhost port 3000 slash. And so, or actually it's without the slash. So that's kind of just the base URL. For the backend, I'm pretty sure it'd be localhost port 8081, I think. And that's what basically the base URL does. And so this line of code is really confusing, but that's all it's just going to say. It's just going to be assigning the base URL to be what is specified in our local environment. The timeout basically says that we're going to give our request 5 seconds to respond. If they don't respond in 5 seconds, then we're going to automatically reject the request, meaning that this helps us to not have infinite requests, meaning that the request is actually never found, but it keeps pending because it's still looking for something. So we're actually giving the request 5 seconds to get back to us, and if it doesn't, then they can just forget about it. And then the last thing is we're including one of our headers. So the content type we're trying to receive from a request, right? If we remember back to the API specifications, is we want our request bodies to be JSON. So that's all this header is saying, is that our content type that we're getting back is going to be of type JSON. And so now we can kind of use this Axios instance to base all of our future Axios requests off of, because we've now have a custom configuration. And so this is very useful for allowing us to make multiple requests and define multiple requests. Any questions on this custom configuration for Axios before we move on to actually making requests? All right, let's go and move on to creating requests. So, quick question, for our application, do we need all 5 requests that we kind of previously mentioned, which is get, post, push, patch, or delete for our blog? So note that we are not supporting changing a blog post or comment after it's made. Basically, what I'm asking is, for our blog, would we need to use all of these methods, or do we only need to use some of them for requesting data? That's right, we wouldn't need patch. Yeah, we definitely don't need patch. And we don't need put either, because we don't need to replace anything in our the backend. Because we say that we're not supporting changing a blog post or comment after it's made, we don't really need to replace it. So you guys are right, we only need get, post, and delete for our blog, and that's all we're going to be using today. So furthermore, yeah, this is basically what I actually just said. What we're going to do next is we're going to use the Axios instance we just created previously to define request within a file we're now going to name api.tsx. And this api.tsx file is just going to hold all the requests we're going to make throughout our application. And when we want to make a request, we can just simply import it from this API file, and that will allow us to use it really easily. So this is what the header uses for our request. And basically, we're first importing the Axios instance from what, the Axios instance we just created. And we're going to import all these types, remember, because we need to type our requests properly. You'll kind of see what that looks like when we define the request, and then below is actually going to be the request. So the first request we're going to talk about is the get request. And so here is an example of how we would get all posts. So this this request is going to be an anonymous function. We can kind of, I'll talk about why we have this export here in a minute, but if you see, this get all post is simply an anonymous function. It's an anonymous asynchronous function, sorry. And we basically type the return type of this function as a promise, because all requests return a promise, and the promise is of type post array, because it's getting all the posts, and we're expecting that we're going to get an array of posts. And so basically the body of this anonymous function is going to be Axios Instance. So this custom configuration we got, .get, which means we're making a get request to our specific URL. So this should have been included over here, but basically what we did, yeah, this should have been included right here, but we defined a const named a post in all capital, and that's simply just the string / posts. And since we're using this as in a lot of places to get data, we figured we just make it a constant. So to I guess make it useful, I guess, in multiple places. So if we want to change where what post is, we just need to change it in one place, and it will get changed throughout our whole application. So this posts thing, it just points to, or is just the string / post. And so what this request is actually saying is, let's get let's make a get request to the backend at the location / posts. The reason we have this $ here, remember, is because we're doing string interpolation, which means that we want to kind of insert the string post into our string that we create here for the request. So remember that our request is a promise. So in order to resolve the promise, we need to have a .then. And so in this case, our .then is going to hold our callback function, and the callback function is just going to be an anonymous function. And that anonymous function is going to respect a response, because that's what a promise is. If a promise is fulfilled, we have a response to the promise. And all we're going to do is just get the posts out of the response by saying response.data.posts. And so in the response object, there's going to be a data field, and in that data field, there's going to be a posts field, and that is what our get all posts are going to do. Any questions on how this works? If there are no questions on how it works, I have a question for you. How do you think we can now get a specific post? So right now, this request gets all the posts from the backend. How do you think we can structure this so that we can get a specific post from the backend? Mind you that getting a specific post is going to be from the URL /post / the ID of that specific post. So how do we first need to incorporate an ID, I guess, somehow into our request. I'll just give you a second to think about that. We're kind of close on time, so I'm going to go ahead and just explain it. So this is basically how we would get a single post. We would take in as a parameter the ID of the post we want to get, and all we have to do is just get from the specific address, and as we said, or the specific location. And as I said, the specific location that we specified for getting a specific post is just /post / the specific ID for the post. And all we need to do is use string interpolation again to kind of include this ID in our get request. And so we're then going to resolve it with the the anonymous callback function, and we're going to take in a response. And this time, the response is going to have a data field, and we're just going to return the data field. And the data field should be the specific post. Yeah, that's how we do a get request. And so let's move on to how we do a post request. So if we want to create a post, that's going to be a post request. similarly to how we just took in an ID to be used in the GET request, a POST request is going to have to post specific data. So the way we need to do this is we're going to take in a post, which is of type create post, and that basically just specifies the fields that we need to use. So we're taking in this post and we want to post it. It's kind of weird with the how we name stuff, but we want to take this post in, this blog post that we created, and post it to the backend. So the way we do this is by using the post method from Axios, and we want to, the post first specifies the location we want to post it to, and so we're going to post the request to /posts, and so the backend basically can decipher between a GET request to a location and a POST request to a location. So that's why we can have a GET request and a POST request to the same location. Yeah. The second argument for the POST request is the post body. So the first argument is where this post is going to go to, and the second argument is what the post is. And basically, the backend will get this body and it will deal with it how it deals with it. How can we now I pose a question to you? How can we clap a post? And note the URL for clapping a post is post/id/clap, and that will clapping is a post action just because that's how it was specified. And so we're running short on time, so I'm going to go ahead and yeah, that is exactly right, Nick. That's what it looks like. Great answer. Yeah, we're just going to take in the ID and we're going to post at this specific request. We don't need a body because we're not I guess posting any body. All we're doing is just posting that we want to clap a specific post. Great answer. Nice. We're going to move on to the delete request, which is our last request. And basically, the delete request simply allows us to delete a post. And it's kind of self-explanatory. We just use the delete, which is going to delete the item at this location in the backend. Really quickly, what we need to talk about really quickly is default exports versus named exports. Default exports are when we export a whole file. And so, yeah, we just say, if you remember, we just say export default, the name of what we want to export, and that kind of exports the whole thing. And named export is specifically exporting a specific part in our file. So if you see the export here, that means we're going to specifically export just this anonymous function. And so that kind of changes how we import stuff. So we import stuff now. If it's a named export, we import it with curly braces. And if it's a default export, we do not need those curly braces. And so this kind of leads me into our last thing really quickly is how do we use these requests in our application? And we first need to do is, let's say we wanted to use our get all posts in our application. We first need to import that from the API, which we do as so. And remember, we have curly brackets around get all posts because it's a named export. And then what we do is whatever we want to use it is all we say is get all posts, which is the function we are importing. And then .then is basically saying with what this return. Remember that we go back all the way over here. Get all posts returns the posts array. So what this does in our application is then we're taking in a post array, right? Because now the .then is taking in a post array because the .then in the API basically broke it down into the post array. And what we want to do is just in our application, we're going to set the post state to what the post array is. And that's as easy as it sounds. Oof, that was a lot of information. I hope it all made sense to you guys. And yeah, that's it for me. just a reminder that we have some of our upcoming events. Next Sunday, I'm pretty sure, is our database basics workshop.
Really quickly, we also have a game night tonight. So if anyone is interested, just show up at 4 and we'll post a link. And I think we're playing. Actually, I have no idea what we're playing. I think Sadaf has it all lined up, but I think we're doing Among Us and a few other games. If you want to play with us, come join.
Yeah, kind of socialize. It'll be nice to kind of take a break and relax. So congratulations on completing the advanced front end. This is kind of where we stop on the front end, and the rest of our workshops are going to be first with the rest of our workshops are going to be dealing with the database design, and then it's going to be dealing with kind of deploying our project. And so after this, you basically created a great front end, and yeah, awesome. No, thank you. I appreciate it. I hope you all have a great rest of your day.